Hi everyone, so this is the video on 4.5, the last two shortcuts for triangle congruence. So we've got a couple review slides here, so we're going to pause the video before each one so you have a chance to do this, so go ahead and do this one. Alright, that one is C, side angle side. This one. Right, this one we do have a reflexive side here, so that comes together to form A, side, side, side. Right, this one. Right, and this one also has a reflexive side, comes together to form side, side, side. Right, number 4. All right, this one is side, side angle. That is not possible. So yes, I know that side, side angle was a choice, but remember that is not a congruence theorem, so we cannot use it. This one. All right, this one is pretty clearly marked for us that it is side, side, side. All right, last one. All right, so this one, if given that A is congruent to R, what sides must you know to be congruent to prove triangle ABC to RST by SAS? So I'm going to sketch the triangle ABC and the triangle RST. And so with that, we know that A is congruent to R. And so we would need AB to RS. So that takes out answers C and D. And we would need to know also that AC to RT. So this is answer B. All right. So now we have our last two congruence theorems, angle, side, angle, and angle, angle, side. So angle, side, angle is exactly what you think it is. It's very similar to side, angle, side. It's just the things that you need are reversed. So instead of two sides and the angle between them, we have two angles and the sides between those. So in this situation, the included side is the same thing as what we had with SAS and the included angle. All right, so let's do a proof with this. This is a very proof-heavy lesson. So it says here, given L is the midpoint of WE and WR is parallel to ED, so I'm going to go ahead and mark those as parallel. And then that's our given, so we want to prove WRL to EDL. So the first thing that I did was I went for the easy one. So I know that we have vertical angles at L. I should name them with 3 letters. So I'm going to say that angle RLW is congruent to angle ELD, vertical angles. Okay. And then the other thing is that we have this midpoint. L is the midpoint of WE. So I'm going to say that WL is congruent to LE. If midpoint, then 2 congruent segments. Okay. And then after that, now I know where the side is, so I have to get the angle on the other end of that side. Actually, I should mark that different than the first angle we used. So we have the next thing, which would be angle W is congruent to angle E. And so then we have, and that would be if parallel lines, then alternate interior angles congruent. And then you see angle, side, angle. So I can say the triangle WRL congruent to triangle EDL by angle, side, angle. All right. So that's how you would use angle, side, angle in a proof. Okay. So the next thing, what we're going to do with this and some of the problems after it. I'm going to give you something, whether that's a statement or reason, and then you're going to have to choose from the answer choices on your screen what we have for the appropriate other thing. So if I give you a statement, you're going to choose a reason. If I give you a reason, you're going to choose a statement. All right. The first part, though, I can write down because it's kind of standard, right? The given AB is parallel to CD, and AD is parallel to CB. Okay. So the next statement is that ABD is congruent to CDB, and CBD is congruent to BDA. All right, so go ahead and choose from the list that's going to appear on your screen the reason for that. All right. The reason for that would be if parallel lines, then alternate interior angles congruent. Okay, next we have the reflexive property, so go ahead and choose the correct statement for that. All right, if you said BD is congruent to itself, that would be correct. And then we have the name of the triangle, and like I've said before, you don't have to feel like you want to get creative with that. Just go ahead and fill in what they gave you as the proof statement. Okay, excellent. Okay, our givens are done for us. Okay, so the next thing, I'm going to give you the statement here, because you probably could figure that one out on your own. So the statement here is that angle S is congruent to angle N. Go ahead and choose, though, from the reasons provided, what the correct reason for that would be. All right, if you said the third angles theorem, it's a weird way to write a T, you'd be correct. The third angles theorem, if you forgot from lesson 1, is the statement that says if I have two congruent pairs of angles in two triangles, then the third pair must also be congruent. And the reason that we have that is because we know that all triangles add up to 180. So if I have two angles that are the same between the two triangles, the third one has to be the same number that's going to add to the two that I already have to make that 180. All right? We're at the last step. So triangle LMN is congruent to triangle QRS. Go ahead and choose the reason. All right? If you said angle, side, angle, then you would be correct once again. Now, with this, I want to point out that we originally had angle. Actually, let me go highlight it now as well. Angle. All right, then we had angle. And then we had side. And so when we had that, we were able to use the third angles theorem, which is something that is always true. I don't need a specific type of triangle or setup of measures or anything like that. It's just two pairs of congruent angles in a triangle. If I have that, the third angle theorem applies. Tongue twister there. So if you have that, all right, what we have shown in this proof is actually something that's very good. It's something that we have in math, and I've talked about this before. We observe different things, and we go and we use them to then prove other concepts. And then because we did that, we get to use our observation in other proofs as a reason. So we showed in this problem that angle, side is enough to show triangles are congruent. And so because of that, I don't need to use that third angles theorem if I have that situation pop up again. I can use angle side. All right, that's just now is something that I'm allowed to use. So let's go through and we'll do the same thing that we did before. So angle M is congruent to angle K, WM parallel to RK. That was given and was also marked on the figure for you. The next thing that I'm going to say is WR is congruent to itself. Go ahead and choose the reason for that. All right, if you said the reflexive property, you would be correct. Okay, all right, so I've got angle inside. I need another something. Okay, so go ahead and answer the question that's about to pop up, which is, can you prove any other sides in this pair of triangles congruent? All right, if you said no, you'd be correct. There is no way to get any other sides congruent here. And so what we have instead is we have to get another angle. And the angle there that we need, it really doesn't matter which one you pick, but it does need to be with the parallel line, sorry. So I'm going to go with that one. And so we've got angle MWR is congruent to angle KRW, alternate interior, I'll give you that one. All right, and then I'll tell you that you're at the end. This is triangle WMR is congruent to triangle RKW. Go ahead and pick the reason there. And this one was an angle side. All right, let's do another one. Okay. We have S is congruent to Q, that was shown to me. And then RP bisects angle SRQ. Okay, that's good. So the next thing would be PR is congruent to itself, reflexive. So then the next thing, again, we have to figure out, we can't get any other sides, but we can get another angle. We know that angle R is bisected by PR. So we can say that angle PRS is congruent to angle QRP. If bisector, then two congruent angles. With this, that's the same idea as what we did before with midpoints. Okay, so then I have what I need. Triangle SRP is congruent to triangle QRP by angle side once again. All right, next one. So this one is going to be a little bit interesting because we have right angles. So we'll have what we have. Angle XWY is congruent to angle ZYW, angle X, angle Z, R, and I'm just going to give the symbol for right angle. All right, the next thing, there's a couple different places you could go with this. I'm going to keep going with something from my given. All right, and I'm going to say that angle X is congruent to angle Z. Go ahead and fill in a reason for that. All right. The reason is that all right angles are congruent. We don't use that very often, but it's something that's obvious to us, right? We know that all right angles are 90. We know that all angles or segments that have the same measure are called congruent, and therefore all right angles are congruent. All right, I don't need to mark anything because it was already marked. All right. The next thing that I'm going to say is that YW is congruent to itself. Reflexive, we've said that so much, we don't really need need to go into that anymore. So then I have what I want. Triangle YXW is congruent to triangle WZY by angle side using the right angle. Okay. All right, so here's just a visual of the 4 shortcuts: side, 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 angle, angle, and angle, angle, side. Okay. There is one more that we'll actually look at in the next lesson, but for right now, there's something else that I want to look at. And that's called CPCTC. That's a little bit of a, mouthful if you try to say it, a couple times fast, but here we go. With the shortcuts that we just talked about, side, 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 angle, side, angle, and angle, angle, side. And then the last one, just put down the letters HL. That's actually the last congruent shortcut that we'll talk about the next lesson. I just don't want you to have to fill this in again. You know how to use congruent parts of triangles to show that the triangles are congruent, right? That's what we've been doing the past couple lessons. We've been taking these congruent parts and we've been using them to demonstrate how the whole triangles are congruent. Once the triangles are congruent, though, you can make conclusions about their other parts because by definition, corresponding parts of congruent triangles are congruent. C, P, C, T, C. And so what that means is it's going back to what we said in the first lesson where we talked about congruent figures, which is that all the sides, all the angles have a partner, a corresponding part in the other one that they are congruent to. Because we've used a shortcut to show the whole figure is congruent to the other doesn't change that fact. So we used a shortcut to get the figures to be congruent, and then we use this reason to extend that understanding to other parts that we didn't use to use the shortcut. So let's take a look at how CPCTC can be used in a proof. So a big clue, just as you're doing these for the first time, a big clue that you're going to use CPCTC at the end of your proof is when, you clearly have triangles, but when your proof statement is a congruence of a segment or angle pair, not a whole figure. So just for reference, let's look at the last one we did. The last one, actually, I don't like that because I don't have the symbol. Let's look at this one. So we had prove triangle SRP is congruent to triangle QRP, and we see, again, we clearly have triangles. But if we look at this one, prove segment KB is congruent to segment AC. So again, that's a big clue of CPCTC. Now, how do I go about this? What I'm looking to do here is I'm looking to take these things. I'm going to do a congruent triangle proof because I need that, right? By itself, using the facts in front of me, I cannot conclude that KB is congruent to AC. I need to go one step further. So I need to get those congruent triangles first, which will then allow me to do this. So how would we start? We start with our given as always. Angle KBC is congruent to angle ACB. Angle K is congruent to angle A. And those things were given, they were marked. I see a reflexive side here at BC. So BC is congruent to itself, reflexive. All right, now I have angle, side. So I'm going to say that triangle. Now here's the thing, I have to be careful because I can't copy the proof statement for my congruent triangle. So I'm going to have to be careful. Okay, so if I say ABC, okay, A was marked congruent to K, B in the top triangle to C in the other one, and then the unmarked angle. So KCB by angle, side Now that I've done that, because the triangles are congruent from angle, angle, side, now I can get those two congruent. So the given and the reflexive lead to the congruent triangles, and the congruent triangles lead to KB is congruent to AC. Corresponding parts of congruent triangles are congruent. Okay? All right. We're going to have you kind of work together with me on one of them, the last one. Okay, so let's put down our givens. BA is congruent to DA. CA is congruent to EA. Okay, next thing. So go ahead and choose a statement and reason from the choices provided. All right, so we have the statement and reason we wanted is angle CAB is congruent to angle EAD, vertical angles. All right, I have enough for congruent triangles, so triangle ABC is congruent to triangle ADE. Go ahead and choose the reason there. Okay, that was a side angle side. And then we have the last piece, angle C is congruent to angle E, what I was asked to prove. And the reason there is the corresponding parts of congruent triangles are congruent. All right, so that is lesson 4.5 on angle side angle, angle side, and CPCTC. Thanks for watching.